Number 2, find the surface area of the surface obtained by rotating the parametric curve. X of t is equal to 1 minus cosine t. Y of t is equal to t minus sine of t, where t runs from 0 to pi over 2 about the x-axis. So a couple things that we know here. We know we're going to need the derivatives, so let's go ahead and compute derivatives of x prime of t and y prime of t. So the derivative of negative cosine 1 minus cosine t is sine t. Derivative down here is 1 minus cosine of t. And our formula is going to have an x prime squared plus a y prime squared in it. And so when we do this, it's going to give us sine of t squared plus 1 minus cosine of t squared. And so we end up with sine squared t plus 1 minus 2 cosine t plus cosine squared t. And how does this simplify? Cosine squared t plus sine squared t is 1. So 1 plus 1 is 2 minus 2 cosine of t. Now, a little trig identity here. This is equal to 4 times sine squared of t over 2, because 1 minus cosine of t divided by 2 is equal to sine squared of t over 2. We're more used to using that in this form. 1 minus cosine of 2t divided by 2 is equal to sine squared of t. We used this a lot to evaluate various trigonometric integrals in the past. This is just replacing t with t over 2, and going from here to here, just multiplying both sides of this by 4. Okay, so what do we need right now? The square root of x prime squared plus y prime squared is going to be the square root of 4 sine squared of t over 2. On the interval in question, t is running from 0 to pi over 2. All of this is positive, so this is just going to be 2 sine of t over 2. Okay, so next slide we're going to start writing down, well, I wrote down the necessary parts for our formula. Well, what is the formula? Maybe I should have let off with this. In general, it's 2 pi times integral from a to b of y of t times the square root of x prime of t squared plus y prime of t squared, all of that dt. And so in this case, a is 0, b is pi over 2, y of t is t minus sine t, and this square root simplifies down to 2 sine of t over 2. Okay, so let's write this down now. 2 pi times integral from 0 to pi over 2 times of t minus sine of t times 2 sine of t over 2 dt. Okay, we want to evaluate this integral. And how are we going to do this? We can do this by, let's see. This can be rewritten as 2 different integrals. Well, we don't like this sine of t over 2, so I'm going to make a substitution that u is equal to t over 2, du is equal to 1/2 dt, so 2 du is equal to dt. And also, this 2 is going to move outside. So that 2 moves outside, there's a 2 coming from here, so it's going to be 8 pi times the integral from 0 to when, so let's see here, when t is 0, u is 0. When t is pi over 2, u is pi over 2 over 2. It's pi over 4. Okay, so this is going to be, if u is t over 2, 2u is equal to t. So we're going to have one integral that is 2u times sine of u du minus the integral from 0 to pi over 4 of, one of this is going to be sine of 2u times sine of u du. Okay, so we have two antiderivatives to find here. Let me go to a new piece of paper to find those antiderivatives before coming back. So one is we want the antiderivative of u sine u du. This is an integration by parts problem. U is equal to, well, u. Forgive the abuse of notation here. We're using u in kind of two different ways. Du is du. dv is sine of u du. And v, the integral here, is going to be negative cosine of u. So this is going to be uv, so minus u cosine u, minus the integral of v du. And so this ends up as minus u cosine u, and then this is plus sine u plus c. So that takes care of one of the antiderivatives we have to do here. For the other antiderivative, integral of sine of 2u times sine of u du. For this one, we're going to use the trig identity that sine of 2u is equal to 2 cosine u sine u. So this is going to be 2 times the integral of sine squared u cosine u du. This calls out for the substitution. W is equal to sine u. dw is equal to cosine w, cosine u, I should have said, cosine u du. So we have 2 times the antiderivative of w squared dw. And so this ends up as w cubed divided by 3 and a 2 factor there, plus c. And w is sine of u. So 2/3 sine of u, sine cubed u, my apologies, plus c. So to finish off everything, there we go, refocus. To finish off everything, this is going to be 8 pi times 2 times the antiderivative u sine u is minus u cosine u plus sine u, minus, this will give us 2/3 of sine cubed of u, and plug in both cases 0 to pi over 4. Let's see, we can do this real quick. 8 pi times, okay, note that when u is 0, that's 0, that's 0, and that is 0. So we only have to worry about the pi over 4. So 2 times minus pi over 4. Cosine of pi over 4 is 1 over root 2. Sine of pi over 4 is 1 over root 2 minus 2/3 1 over root 2 cubed. And there's our final answer. It surely can be simplified, but we will call it quits here.